In this video, we're going to look at an introduction to sequences. So let's start with the definition of a sequence. A sequence is a function. It's a special type of function. It is a function whose domain is the set of positive integers or natural numbers. Let's just write it this way. This would be, in a textbook, they would say what this is, all right? Positive integers or natural numbers. Now, I will say that if it's not stated, then you should assume that this is the domain. The domain can be adjusted to start at 0 or other integers, but it's always going to be integer values. So let's take a look at an example of a sequence. So this is the notation for a sequence right here. A sub n, this is the output, and n is the input. So we're starting with 1. So we would write a sub 1, and then we would plug in 1 for the n values. And that would get 0. A sub 2, and then we would plug 2 in for the n values. And that would be a half. A sub 3, we would plug 3 in for the n values. And that would be 2/3. Oh, let's do a couple more. A sub 4. Put 4 in for the n values, and hopefully you can see the pattern here. And the fifth term is 5 minus 1 over 5, which is 4/5. So we could write the sequence out: 0, 1/2, 2/3, 3/4, 4/5. And actually, if we write the 0 before it gets simplified, we can really see the pattern, the numerator increasing by 1 and the denominator also increasing by 1. And then we would want to go dot, dot, dot to show that this goes on forever. So the next thing we're asked to do is graph the sequence. Well, what we're going to have is a series of points. We're going to have our n value and our a sub n. We're not going to connect these points because we're not considering n values that are fractional. So our first n value is 1, and our output was a sub 1 was 0. When n is 2, a sub n is a half. When n is 3, a sub n is 2/3. 4, 3/4, 5, 4/5. So we're literally going to plot these points. All right, let's go take a look at that graph. So here on Desmos, I've put in, using n as the input, a of n as the output. So this isn't a times n. This is like function notation. Input n and output n minus 1 over n. And you can see it's giving me all values of n, which I don't want. I don't want n to be fractional or decimal. I want it to be only positive whole numbers in this situation. So here's how we can tell Desmos to just graph the points that we want. So I'm going to go n, capital N, and this is distinguish it from a lowercase n, equals bracket, and I'm going to make a list here. 1, 2, 3, dot, 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 up to, let's go 10. Okay, so I have 10 elements. Now I'm going to come down here and I'm going to ask Desmos to plot some points. So the input of the point, the x value of the point, is capital N, and the output of that point is a of capital N. Okay, here we go. A of capital N. Get my typing. There we go. There's my point. Okay, so there's the points that I want. Now I'm going to turn this off. Okay, I'm going to turn that off. Now I can see my values. So here's our points. 2 and comma half, right? These are the points from our list that we had a second ago. And you could do as many elements as you want. I could make this final element 100. Right? And we could see that this looks like it's going to not get any bigger. It's going to approach a certain number. It's going to approach 1, right? Because the numerator and the denominator, the y value, the output's going to approach 1. The numerator and the denominator are going to become very close to each other. All right, let's try this one. Let's try part B. So pause the video and list out the first 5 elements of B sub n. All right, so this is what you should have. Now, one thing I want to highlight is the fact that this is going Positive, negative, positive, negative. And what is causing that? Well, what is causing that is this right here, all right? This part of the formula, the only thing that's doing is changing the values from positive to negative. It's not really affecting the absolute value of these outcomes. It's just changing it from positive to negative. If I left this whole yellow piece out, then I would just get 2, negative 1, 2. I would get 2, positive 1, 2/3, positive half, 2/5. So when it comes to writing formulas, this is a good thing to remember. If you want your terms to move from positive, negative, you need to include some kind of a multiplication of -1 to a power. All right, let's take a look at what that graph is going to look like. So I changed this to b sub n, and I put our b sub n formula in, and then I just changed this a to a b, and we get this right here. Let me take these highlighted points off here. There we go. So this is what happens with your sequence when you go, positive, negative, positive, negative. And we can see what's happening is the values are approaching 0 from the top and the bottom. This is called an alternating sequence, hopefully for obvious reasons. All right, let's try the next one. C sub n equals n if n is even, and 1 over n if n is odd. Pause the video and list out the first 5 terms of that sequence. All right, this is just a matter of following the directions. So C sub 1, 1 is odd, so my answer is 1 over 1, which is just 1. All right, C sub 2, well here n is even, so if n is even, then the output is just n, so C sub 2 is 2. And that'll be for all the even ones. C sub 4 is 4, C sub 6 is 6. For the odd ones, it's going to be 1 over n, so C sub 3 is 1 over 3, and C sub 5 is 1 over 5. So if I wrote out my sequence, I would go 1, 2, 1/3, 4, 1/5, 6, and I hopefully can see the pattern, and I could keep going. Now the next thing we're going to do is you're going to be given the sequence and you have to figure out the formula. And basically that's like a little puzzle. This one would be a tricky one. You might not think that, oh, I got to write basically a piecewise function, 2 sets of directions. Now where these other 2 examples, there were, like one formula. It's not always like that. All right, let's take a look at something like that. Determine the formula for this sequence. Let's look at A together, and then maybe you can try some of these other ones. All right, well, what do I see? I see that I've got e to the first, e to the second, e to the third, e to the fourth. I basically have a fraction. Now, the first term isn't written as a fraction, but I can write it as a fraction by putting it over 1. And when I do that, I can see the pattern of the denominator is 1, 2, 3, 4. All right, so I'm going to say a sub n equals, and then basically I'm going to write a formula for the numerator and a formula for the denominator. Well, the numerator is going e to whatever n is, right? So I say e to the n. As far as the denominator goes, well, that's just the n value. So the denominator is 1, 2, 3, 4, so this is just n. And that is your formula. Now, if you wrote it like they're doing up here with these brackets, let's see, these brackets up here, writing everything in brackets, that's a typical sequence notation. Then we could say the sequence a sub n is equal to the set of outputs e to the n over n. All right, why don't you try B, C, D, and E and see what you can come up with. All right, hopefully you've taken some time to think about that. So what I see here with B, I'll just call this B sub n. The numerator is staying as 1, and the denominator is looking like powers of 3. So if I write 3 to the n, let's say, then B sub 1 would be 1 over 3, but I don't want that to be 1 over 3. I want it to just be 1. So in order to make that happen, I make this to the n minus 1. So then this is going to be 3 to the 0, which makes this 1 over 1, or 1. And it's a good way to check your formulas, just check a few points. So B sub 2 would be 1 over 3 to the 2 minus 1, which is the third. Good, that's what I want. I want my second term to be a third. So this is my answer. Now C is growing linearly, isn't it? It's increasing by 2 each time. So remember, you're starting on 1, so this is a little bit tricky, but the way that you can make this work, since you're starting at 1 and you're increasing by 2 each time. If it was linear, you would just write 2n, but then 1 would be your sort of like y-intercept when n is 0, but we want that to be when n is 1. So again, we're going to go n minus 1 in these parentheses. And maybe you thought about it a little differently. If we simplify this, we get 2n minus 1. All right, you could certainly have gotten to that by thinking, oh, this is like 2, 4, 6, 8, but 1 less than that. All right, how about D? Did you recognize D? We have 1, which is 1 squared, and then we have 4, which is 2 squared, and then we have 9, which is 3 squared, and 16, which is 4 squared. And I think we're seeing the pattern. Oh, not 5 squared. Seeing the pattern now. So my formula is going to be n squared. That's all it is. 1 squared, 2 squared, 3 squared, 4 squared. All right, my last one has got some stuff going on. I've got 1's in the numerator the whole time. The bottom is just going 1, 2, 3, 4, 5, so that's n. But then I've got this positive, negative business. So to make that happen, I have to introduce a factor of -1 to some power. Now this is either going to be up here, this is either going to be n or n minus 1 or n plus 1, and you have to make it work so the first term is positive. Now if you want the first term to be positive, then you need the exponent to be even. So if I just put an n in there, that's not going to be even, right? Because I'm starting with 1. So I can either do n plus 1 or n minus 1 up here in this numerator. And then when I plug in 1 for n, that's going to make this even, which will make my first term positive. When I plug in 2 for my second term, it'll make -1 to the third, which is odd, which will make my answer negative, which is what I want. So that is the formula for that one. We'll call it E sub n. Now factorials are something that come up sometimes when you're dealing with sequences and also in counting. And what a factorial means, let's say if we have something like n factorial, it's an exclamation point. And you can find that on your graphing calculator if you hit the math button. And then you got to scroll over to PROB, that stands for probability. And then it is option number 4. You'll see that factorial. So what this does is whatever number you put in for n, let me do an example without n. Let's say we have 5 factorial. You're going to start with the number 5, and then you're going to decrease by 1 until you get to the number 1, and you're going to multiply all those together. All right, so 5 times 4 is 20, times 3 is 60, times 2 is 120. 5 factorial is 120. So if you go to your calculator and you punch in 5, and then you hit the math button, go over to probability, hit 4, and paste this in here, your calculator should say 120. So the way we would write this out is we would say, okay, start at n. Now you're going to multiply n by 1 less than that, which is n minus 1. And then you're going to multiply again by 1 less than that, n minus 2. And you keep doing this until you get down to 3, 2, 1 or 2, 1. All right, and that would be the formula for n factorial. This actually comes up in counting. Let's say you had 5 people in a race, and you wanted to ask the question, how many ways could those 5 people finish the race? Well, there'd be 5 options for first place, then 4 people left that could finish second, then 3 people left that could finish third, the last 2 people fighting for 4th place, and then that last person finishes 5th, and you multiply all those together, and there's 120 possible ways for 5 people to finish a race, or to arrange 5 books on a shelf, something like that. All right, so the next thing we're going to look at is something called a recursively defined sequence. So we looked at some sequence definitions up here, and these are just basically like formulas, all right? These are, written in such a way that you can just start plugging in 1 for n and off you go. All right, so in this formula, these recursive formulas basically require you to use the previous term in order to determine what the next term is. So let's take a look at this first example. So it's telling me that my first term is 1. All right, right here, my first term is 1. So let's say over here, I'm going to write out the first 4 terms. So my first term, my second term, my third. These aren't fraction bars, all right? They're just like lines where I'm going to write the terms in. And then we're going to put commas between them. So I'll do it in a different color, all right? So my first term is 1. Now what's my second term? Okay, let's look at this formula. Let's let n be 2. So I'm going to put 2 in where these n's are. 2, and then s sub 2 minus 1. So in other words, s sub 2 equals 2 times s sub 1. So what that's telling you is you have to take s sub 1 and multiply it by 2 to get s sub 2. So that's going to be 2. All right, let's try s sub 3. All right, let's erase these. Let's erase these. Let's say I want s sub 3. Got to erase this too, right? So n is 3, so I'm going to put a 3 where the n is, a 3 where that n is, so I get 3 times s sub 2. So that means I'm going to take s sub 2, and I'm going to multiply that by 3 to get my next term, which is 6. All right, let's go for s sub 4. S sub 4, are you seeing the pattern here? S sub 4 is 4 times s sub 4 minus 1. So s sub 4 is 4 times s sub 3. Well, s sub 3 was 6. So I have to times this by 4, and that would be 24. So can you guess what the next term would be? Yeah, we'd have to multiply by 5, the previous term by 5. So my next term would be higher math 120, and we would keep going. Now this would be difficult sequence to write a formula like this. Sometimes recursive formulas are easier to write. This is a very famous formula right here written recursively. So it's actually telling us our first 2 terms. So it's telling us our first term and our second term. Let's write out a few of these, see if you recognize this one. Our first term is 1. Our second term is also 1. Now, how do we find the third term? All right, let's look at this formula right here. So I want to find u sub 3. So what I'm going to have to do is let n equal 1. Now, this is a little tricky, but let's write this out. If I let n equal 1, I'm going to put 1 where all the n's are, okay? So it's going to say u sub 3 equals u sub 1 plus u sub 2. I put, let me make this smaller, that's too big. I put 1 where all these n's are. So what is that saying? Well, that's saying the third term equals the sum of the first 2 terms. So that means that u3 is 1 plus 1, or 2. All right, let's let n equal 2. So n equal 2 in this formula is not saying the second term, right? Because if I'm letting n equal 2, then I get this statement, this formula is telling me u sub 4 equals u sub 2 plus u sub 3. So I have to take the second term plus the third term to get the fourth term, and that would be 3. So basically what this formula is telling you is to find any term, you take the sum of the 2 terms prior to that term. All right, so u sub 5 is going to be 2 plus 3, which is 5. Do you recognize this sequence? 1, 1, 2, 1 plus 2 is 3, 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. This is the Fibonacci. I wonder if I could spell this. Let's see. Oh, C, it's got 2 C's in it. Fibonacci. There we go. If you want to go down a rabbit hole, Google Fibonacci sequence. A lot of fun stuff going on there. All right, so summation notation. This is super important, and we talked about this a little bit in class, but let's remember what this means. We're going to take this formula right here. We're going to take this formula, and we're going to start with the k value at the bottom, which is k equals 1, and we're going to go up to the top number, which in this case is n. So our last term is just going to have an n in it. All right, so let's write this out. So we're going to plug in 1 for k. So I get 1 over 1 plus 1, which is 2. And then what does this summation mean, right? It means the sum. It means we're going to add everything up. All right, so my next term, let me write under here just for, was k equal 1. Okay, so now when k equals 2, I'm going to get 2 over 3, and I'm going to add those together. That's what the summation tells me to do. All right, how about k equal 3? I'm going to get 3 over 4. Let's do one more. K equal 4, and that's going to be 4 over 5, and then I'm going to keep going. Now, how do I know when to stop? Well, this tells me that I want to stop when k equals n. Now that's a little bit weird, but we can write it out. All right, so k equals n. I'm just going to plug n in for k, and I would leave it like that. All right, that would be starting with a k value of 1 and ending with a k value of n. And I can't find that sum because I don't know what n is, but that would be how we would write out the summation notation. All right, you try B. Now notice here it's starting at k equals 0, so that's a classic example of how I said earlier, you don't always have to start at 1. Here we're starting at 0. So pause the video and give that a try. All right, how did you do? How's that look? Again, we can't find the answer here because I don't know what value of n that I want to end with. All right, so now we're given a summation notation here, or we're given an expanded notation. We would call this expanded. And we want to rewrite it in summation notation. So basically we're going backwards from what we did up here. So the first thing we need to do is sort of ignore the plus signs and look at it as a sequence and see if we can come up with the formula. So as a sequence, I've got 1 squared, 2 squared, 3 squared, all the way up to 9 squared. So can you think of a formula for that? Right? It's just n squared, right? That's all it is. Okay, pause the video and see if you can write that as a sum. Okay, so we're going to get our big summation. We're going to put our formula in here. And what do we want to start? We want to start with n equals 1. And what are we going to end with? We're going to end with 9. All right, so that would give me that expanded notation. Okay, go ahead and see if you can do a summation notation for part B. Now, B is actually giving you some good information here. This last term has the n's in it, right? It's actually the formula. Notice when we did these up here that had a top input of n in the top of the summation, the last term was just the formula with n's in it. Okay? Here was the formula with n's in it. So I can say I'm going to start, since that has n's in it, I'm going to start from k equals 1 to n of 1 over 2 to the k minus 1. It's basically giving me the formula. Now there's some properties of sequences here that you should read through, and some of these are kind of fun to prove. We're not going to do that in this video. We're going to finish up with this, and we're going to do a couple of these by hand, and then you can do the rest with your calculator. But now these we can actually find the sum. All right, so for this first one, let's do this one by hand. So we're going to put in 1, and we'll get 3. And we'll put in 2. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15. And so we're just going to add all these up. All right, so that's 18 plus 12 is 30, 45. Now, your calculator will do this, and so if you need to Google how to do summations on your calculator, go ahead and do that. Certainly, I would want to do that for this problem. I don't want to do that by hand. And notice on this problem, it's kind of interesting because it's starting at k equals 6. So your first term is going to be 4 times 6 squared. And then your second term is 4 times 7 squared. And we're going to go all the way up to 4 times 20 squared. And we can add all those up. Make sure to obey the order of operations and do your exponent first and then multiply by 4. So let's just go take a look at how we would do this one on a TI-84 calculator. So let's go over here. We want to hit mode and put ourselves in sequence mode. It'll actually do it in function mode as well. But let's put it in sequence mode and go back to our home screen. And now I'm going to hit math and scroll down to option 0, or I can just hit 0. I should show you that. Let me show you that again. Clear math, scroll down to option 0. So that's the summation. All right, I just hit 0 and then it pasted it on the screen. Okay, so now I'm going to say I want to go from n equals, what was it, 6, right? N equals 6 to 20. Now, your calculator is saying n, so it's using n for your variable. That's fine. We're going to go n equals 6 to 20 of 4n squared. N equals 6 to 20. 4n, so this x button now becomes the n because of the mode we're in. Squared, enter, and the sum is 11,260. All right, 11,260. All right, if you want to try B and C with your calculator, go ahead and pause the video and do that, and when you unpause it, you will see those answers. So I wrote out the first few terms. That's always good practice. It's not necessary if you're using your calculator, but the first few terms of B and then my sum, 3,035. And the first few terms of C with my last term, you'll notice that the terms start off negative, but they will become positive at some point when the k squared starts outweighing the minus 7k, and we'll end up with a positive sum. And actually, you might, if you graphed these points like we did at the beginning, you would end up with a parabola, right? This is basically a quadratic. So they're getting the y values, the outputs are getting smaller, and then eventually they come back up again. All right, well, I hope that this introduction to sequences and series was helpful.